On the 18th of July, a thermometer on the high plateau of East Antarctica read minus 84.1 degrees Celsius, the coldest air measured anywhere on this planet in 14 years. That same day, 7,000 miles north, a city in Argentina recorded the hottest night in 101 years of observations, 23 degrees above normal in the dead of its winter. Opposite extremes, same hemisphere, same afternoon. Nearly every report treated that as coincidence. It is not. One structure sitting over Antarctica produced both, and depending on whether it holds or fails, it delivers either the coldest air on Earth or the largest warm anomaly ever recorded on this planet. This July it held, and the gap it opened between the two ends of the world reached 136 degrees. If you want the mechanism underneath the headline and not just the number, subscribe to the Sky Lab and give this one a like on the way past. Drop a comment telling me where you're watching from and what the temperature is outside your window right now, because I would like to see the spread across this audience. Now, let's get into it. Part 1. The number that came out of the dark. On July 18th, 2026, a thermometer on the high plateau of East Antarctica read minus 84.1 degrees Celsius. In Fahrenheit, that is minus 119.4. It is the coldest air temperature measured anywhere on this planet in 14 years. The reading came from Concordia Station, a French and Italian research base that sits more than 10,000 feet above sea level on the interior ice sheet, roughly 700 miles from the nearest coast in any direction. Concordia is one of only 3 inland bases on the entire continent where human beings stay through the winter. On the day that number appeared, the sun had not risen there in months, and it would not rise again for weeks. There is a stretch of the year at Concordia when the sky simply does not brighten, and July sits in the middle of it. Now hold that number in your head, because I want to put another one beside it. On that same calendar day, roughly 7,000 miles to the north, the city of Salta in northwestern Argentina recorded the hottest night in its instrumental history. The overnight low temperature never fell below 26 degrees Celsius, that is 78.8 degrees Fahrenheit, as a minimum at night, in the middle of the Southern Hemisphere winter, in a record series that runs back to 1925. Against the normal for that date, the anomaly was plus 23.2 degrees Celsius. Same day, same hemisphere, same season. One place produced the lowest temperature on Earth in over a decade. The other produced the warmest night in a century of record keeping, and almost every piece of coverage I have seen treated them as 2 unrelated curiosities that happened to land on the same page of the calendar. They are not unrelated. That is the whole reason I am making this video. There is a structure sitting over Antarctica right now, and it is the reason both of those numbers exist. It is made of wind. It is roughly the size of a continent, and depending on whether it is holding or breaking, it can deliver the coldest air on the surface of this planet, or it can deliver the largest warm temperature anomalies ever measured anywhere on Earth. Not different structures, the same one, operating in 2 different states. This July, it held unusually well. Let me give you the first piece of the machine before we go anywhere else, because I do not want you sitting through 20 minutes of setup before you get an answer. In the stratosphere above Antarctica, roughly 10 to 30 miles up, a ring of extremely fast westerly winds encircles the continent every winter. Scientists call it the Antarctic Stratospheric polar vortex. I am going to call it the lid, because functionally that is what it does. It isolates the air underneath it from the rest of the planet. When that lid is intact and tight, the air trapped beneath it is sealed off from the warmer air of the middle latitudes. It cannot mix, it cannot be replaced, and through months of unbroken darkness, it does the only thing it can do. It radiates its heat away to space, and nothing arrives to replace what it loses. The temperature falls, and keeps falling, until it approaches something close to a physical floor. That is what produced the number at Concordia. We can measure how tight the lid was, and this is where it gets interesting. There is an index that describes the state of that circulation, called the Antarctic Oscillation. You will also see it written as the Southern Annular Mode. Positive values mean a strong, tight, well-organized vortex. Negative values mean a weak, wobbly, leaking one. In late June of 2026, that index surged to plus 5.0. Plus 5 is not a normal reading. It is an extreme one, and forecast guidance had it staying at plus 2 or stronger through the first third of July. The lid was not merely present this winter, it was locked. And when a lid that size locks, the effects do not stay under it. This is the part that connects Concordia to Salta, and it is the part I want you thinking about for the next 2 hours, because everything else in this story hangs off it. A vortex that intense, sitting in a specific position over the continent, does not just chill the air beneath itself, it organises the atmosphere around itself. It bends the path that weather systems take thousands of miles away. It decides, in a real and traceable way, where warm air goes on the other side of the Southern Ocean. So the record cold in Antarctica and the record warm night in Argentina are not a coincidence that happen to share a date. They are two outputs of one machine. I will show you exactly how that works, and I will show you the specific geography of it, because the position of the vortex core this year is the detail that makes the connection concrete, rather than hand-waving. But first I want to be honest with you about the easy explanation, because it exists and it is partly true, and I would rather deal with it now than have it nagging at you. The easy explanation goes like this. Of course, there is an enormous temperature difference between Antarctica and the rest of the world in July. The Northern Hemisphere is at the peak of summer. Antarctica is in the depth of polar night. Every July produces a huge spread between the hottest and coldest points on Earth. Nothing to see here, and as far as that goes, it is correct. Seasonal contrast is real, it is expected, and it explains a large part of why the global temperature range looks so extreme in the middle of the year. I am not going to pretend that a cold Antarctic winter is mysterious, because it is not. Antarctica is supposed to be brutally cold in July. That is the baseline, not the anomaly. What the seasonal explanation does not touch is any of the following. It does not explain why the Antarctic Oscillation hit plus 5.0. It does not explain why most of the continent was running more than 20 degrees Celsius below normal, which is a departure from the baseline, not the baseline itself. It does not explain why a city in subtropical Argentina broke a 100-year-old record for warm nights on the same day, in the same winter, in the same hemisphere. And it certainly does not explain the thing I'm going to show you in the second act of this video, which is that this same continent, in this same winter, also set a heat record. That last one is worth saying again slowly, because when I first put the two data points side by side, I assumed I had made an error. Antarctica set a record cold reading and a record warm reading in the same winter. On June 6th of this year, Esperanza Base, on the northern tip of the Trinity Peninsula, recorded a winter record of 15.4 degrees Celsius, that is roughly 60 degrees Fahrenheit, in Antarctica, in winter. Other stations in that region logged similar record warmth, and for nearly 3 straight weeks, daily maximum temperatures there stayed above freezing. The result was melting severe enough that bare ground appeared at the mountain bases of the Collins Glacier. Bare ground. On a glacier. In the middle of the Antarctic winter. 6 weeks later, on the other side of the same continent, the air temperature fell to within 5 degrees of the lowest reading ever taken on this planet. If you have been watching this channel for a while, you know I try very hard not to overstate things, and you know that when the data is boring I say so. This is not one of those days. What we are looking at is a single continent producing both ends of Earth's temperature range in a single season, and the mechanism that decides which end you get is the same in both cases. The lid holds, and you get the coldest place on Earth. The lid fails, and you get the largest warm anomalies ever recorded on the planet. We have now watched it do both inside of 2 years, and I'm going to walk you through the second case in detail later, because it has been studied, published, and attributed, and the findings are genuinely startling. Here is where I want to leave you before we go deeper into the physics. The number from Concordia has already started doing something out in the world, separate from anything it means scientifically. Within hours of it appearing, it was being circulated as proof that the entire warming story is a fabrication. Coldest temperature in 14 years. There is your climate crisis. In at least one prominent packaging, it was bundled directly alongside political stories about official climate documents being reviewed for fraud. I am going to take that argument seriously in this video, because parts of it come from a real and reasonable frustration, and because dismissing people rarely persuades anyone of anything. There is a version of that complaint that is legitimate, and I will tell you exactly which version. But I am also going to show you the number that makes it collapse, because minus 84.1 is not the coldest temperature ever recorded on Earth. It is not particularly close. The actual record is minus 89.2 degrees Celsius, and it was set at Vortex Station on July 21st, 1983, 43 years ago. and this reading missed it by more than 5 degrees. So the question is not whether the planet is cooling, because a record that falls 5 degrees short of a mark set before most people watching this were born is not evidence of cooling. The question is, what kind of system produces a near-record cold reading and a record melt event on the same continent in the same year, and what that tells us about where this is going? To answer that, we need to go to Concordia and understand exactly why that particular patch of ice is capable of getting colder than anywhere else on the surface of this world. Part 2. What it takes to get that cold. 10,000 feet. That is the first number that matters about Concordia, and almost everything else about the station follows from it. The East Antarctic plateau is not a flat sheet of ice at sea level. It is a dome. The ice piles up in the interior of the continent to depths of more than 2 miles in places, and the surface of that ice rises with it, so that standing at Concordia puts you at an altitude comparable to a high mountain pass in the Rockies, except that in every direction the horizon is the same featureless white, and the ground beneath you is frozen water rather than rock. Altitude matters for temperature in the ordinary way that anyone who has driven up a mountain understands. Air thins as you climb, and thin air holds less heat. But at Concordia the altitude does something more specific than that, and it works together with a second factor that turns out to be even more important. The air on the plateau is extraordinarily dry. I want to spend a moment on this because dryness is the least intuitive part of extreme cold, and it is doing more of the work than most people assume. Water vapour is a greenhouse gas. That is not a controversial statement or a political one. It is simply a description of how the molecule behaves. Water vapour absorbs infrared radiation coming up off a surface and re-emits some of it back downward. In a humid place, the atmosphere throws a fraction of the escaping heat back at the ground continuously, which is why a humid night cools slowly and a desert night cools fast. Now take that effect and push it toward its limit. At -60 or -70 degrees Celsius, the amount of water vapour air can hold collapses toward almost nothing. Cold air simply cannot carry moisture. So the atmosphere above Concordia in midwinter is close to the driest air on the planet, and it is throwing almost nothing back down. Heat radiating up from the ice surface goes out towards space largely unimpeded, and that produces a feedback that runs in one direction only. The surface cools because the air is dry. The air becomes drier because the surface is cooling. There is no mechanism in the middle of the plateau, in the middle of the polar night, to interrupt it. Which brings me to the third factor, and it is the simplest one. There is no sun. At Concordia's latitude, the sun stays below the horizon for roughly 4 months. Not dim, not low, below the horizon, continuously, for a third of the year. The energy input that drives essentially every other temperature pattern on this planet is switched off entirely, and the only heat available to that patch of ice is whatever was already there, plus whatever the atmosphere manages to transport in from somewhere else. Hold on to that last clause, because it is where this connects back to the lid. Under normal circumstances, even in polar night, some warmer air does find its way in. The atmosphere is not a set of sealed compartments. Weather systems push poleward, storms carry heat and moisture down from the ocean, and the plateau gets intermittent deliveries of warmth that interrupt the cooling and reset it partway. The temperature drops, something arrives, it rises, and then it drops again. What happened this July is that those deliveries stopped. The vortex was so tight and so well organised that the interior of the continent was effectively cut off. No intrusions, no resets, just the ice, the dark and the dry air, losing heat to space day after day with nothing coming in to replace it. And when you leave that process running long enough without interruption, the temperature does not stabilise somewhere comfortable. It keeps descending toward whatever floor the physics allows. On July 18th, it reached -84.1. This is why the reading matters more than the number alone suggests. A single cold temperature is just a temperature, but a temperature that low at that station tells you something specific about the state of the atmosphere above it, in the same way that a very high fever tells a doctor something about a process happening elsewhere in the body. The reading is a symptom. The lid is the condition. There is a comparison here that I think makes it concrete. The coast of Antarctica in the same winter was nowhere near this cold. Coastal stations sit at low elevation, next to an ocean that never drops below roughly -2 degrees Celsius, because that is where seawater freezes, and they are exposed to the storm systems that circle the continent. The ocean acts as an enormous thermal reservoir, and the coast is close enough to feel it. The plateau is not. The plateau is high, dry, dark, far from the water, and this year it was also sealed. Every single factor that could have moderated the temperature was either absent or blocked. There is a fourth factor at Concordia that I have not mentioned yet, and it is the one that turns an already extreme situation into a record-producing one. It is called a surface temperature inversion. In most of the world, temperature falls as you climb. Warm ground, cooler air above it. On the Antarctic plateau in winter, that arrangement turns upside down. The ice surface is radiating heat away so efficiently, and there is so little to interrupt the process, that the surface becomes colder than the air sitting above it. The coldest air in the entire column is the thin layer in direct contact with the ice. That inversion can be enormous. On the plateau in midwinter, the temperature difference between the surface and the air a few hundred meters up can run to 20 or 30 degrees Celsius, with the ice at the bottom of that gradient. The reason this matters is that an inversion is stable. Cold air is dense, so it sits where it is. There is no buoyancy, no convection, nothing rising and mixing and carrying warmer air down to the surface. In a normal atmosphere, turbulence constantly stirs the lowest layers and prevents extremes from concentrating. On the plateau, that stirring stops. The cold pools, undisturbed, in a layer sitting directly on the ice, and the thermometer at instrument height is sitting inside it. So the record at Concordia is not measuring the temperature of Antarctica in any general sense. It is measuring the bottom of an inversion on the highest and driest part of the continent, in the middle of the polar night, in a winter when nothing was allowed in to disturb it. Every one of those conditions has to be satisfied at once. Remove any single one and you do not get a number like -84. That cold, dense air does not stay put forever, incidentally, and what it does next is one of the more striking things about this continent. Because the plateau is a dome, the pooled cold air eventually begins to flow downhill under its own weight, accelerating as it descends toward the coast. Those are the katabatic winds, and in places where the terrain funnels them, they reach speeds comparable to a hurricane. The continent is, in a sense, constantly draining its own cold toward the sea. There is also a question of how you measure a temperature like this at all, which is less trivial than it sounds. At -84, ordinary instruments have problems. Standard mercury thermometers are useless, since mercury freezes at around -39 degrees Celsius. The measurements come from electronic sensors housed in ventilated shields, designed to keep the instrument at air temperature, rather than letting it exchange radiation directly with the sky or the snow, and those shields matter enormously in an environment where the sky is effectively a heat sink at a temperature far below the air. This is also why the recognized record has to specify what kind of measurement it is, and it is worth being precise about the standard. An official air temperature record is taken at a fixed height above the surface, in a ventilated shield, by a calibrated instrument at a permanent station. That definition is what allows a reading from 1983 to be compared to a reading from 2026 at all. That combination is why the lowest temperatures ever recorded on this planet all come from this one region. Not from the Arctic, which is an ocean surrounded by continents rather than a continent surrounded by ocean, and which therefore always has water underneath the ice moderating things. Not from Siberia, which gets brutally cold but sits at lower elevation with a very different circulation. The East Antarctic plateau holds the record because it is the only place where all of those conditions stack in the same location. The mark it is measured against was set at Vortex Station, another interior plateau base, on July 21st, 1983. -89.2 degrees Celsius, -128.6 Fahrenheit. That figure has stood for 43 years, and by an accident of the calendar its anniversary falls within days of the reading we're discussing. Concordia missed it by 5.1 degrees. Now, there is a wrinkle here that I want to handle honestly, because if you go looking you will find lower numbers than -89.2 attached to Antarctica, and I do not want you to think I am hiding them. Satellite instruments measuring the temperature of the snow surface itself rather than the air above it have identified pockets on the East Antarctic plateau reaching somewhere in the range of -93 to -98 degrees Celsius. Those are real measurements. They are also a different kind of measurement. They are remote-sense skin temperatures of the ice, in small hollows, under ideal conditions, and they are not standard air temperature observations taken at instrument height by a weather station. The recognised record is an air temperature record, taken the way air temperature has been taken for a century and a half, and that is why Vostok still holds it. If you compare a satellite skin reading to a station air reading, you are comparing two different quantities, and the comparison will mislead you. I mention this because measurement questions are going to come back later in this video from the other direction entirely, when we get to the hot end of the range, and the same principle applies there. So we have the physics of why the plateau can get that cold, and we have the specific reason it did this year rather than some other year. What we do not yet have is the shape of the thing doing the sealing. I have been calling it a lid, which is a useful image but a vague one, and it is time to be precise about what it actually is, how it forms, and why this particular winter it locked down harder than it has in over a decade. Because the moment you understand its structure, you will also understand how something sitting over the South Pole ends up writing the weather forecast for a city in Argentina. Part 3. The lid. Picture the Southern Hemisphere from above the pole looking straight down at Antarctica. Every autumn, as the continent tips away from the sun and the polar night begins, a temperature contrast builds in the stratosphere between the freezing air over the pole and the sunlit air further north. Air does not tolerate a contrast like that sitting still. The difference in temperature creates a difference in pressure, and the difference in pressure drives wind, and because the planet is rotating, that wind does not blow straight from the warm side to the cold side. It gets deflected, and it curls, and what forms is a ring. A ring of westerly wind circling the entire continent in the layer of atmosphere roughly 10 to 30 miles above the surface. In midwinter, the winds in that ring can exceed 200 miles an hour. That is the Antarctic Stratospheric polar vortex. And the reason I keep calling it a lid is that its practical effect is containment. The air inside the ring is not free to mix with the air outside it. The ring behaves like a wall in the atmosphere, and the stronger the winds, the harder it is for anything to cross. Everything about the temperature at Concordia depends on the integrity of that wall. When the vortex is strong and symmetrical and centered over the pole, the cold air inside it is quarantined. It just sits there getting colder, night after night, with nothing able to reach it. When the vortex is weak, or stretched, or shoved off center, the wall becomes leaky. Warm air pushes in from the middle latitudes. Cold air spills out. The whole system mixes, and the extremes at the center get shaved off. So the question every Antarctic winter is not really whether it will be cold. It is always cold. The question is how well sealed it is. We have a number for that, and I mentioned it earlier. The Antarctic Oscillation Index, which you will also see called the Southern Annular Mode, is essentially a measurement of how organised and how strong that circulation is at any given moment. Strongly positive means tight and locked. Negative means weak and leaking. In late June of 2026, that index surged to plus 5.0. I want to be clear about what a value like that means, because index numbers can wash over you without landing. These indices are constructed so that most of the time they wander around within roughly 1 unit either side of 0. A reading of plus 2 is notable. Plus 3 is unusual. Plus 5.0 is at the far edge of the distribution, and forecast guidance had the index holding at plus 2 or stronger through the first 10 days or so of July. It is worth pausing on why the Antarctic vortex behaves so differently from its northern counterpart, because the contrast explains why a reading like this comes from the south rather than the north, and it sets up everything that happens later in this story. There is a polar vortex over the Arctic too, every northern winter formed by the same basic process. But the northern hemisphere is a mess of continents and mountain ranges. The Rockies, the Himalayas, the great land and ocean contrasts of the northern middle latitudes all disturb the flow of the atmosphere and generate enormous planetary scale waves that propagate upward and batter the vortex constantly. The Arctic vortex is therefore chronically unstable. It stretches, it wobbles, it splits, and it is disrupted by sudden stratospheric warmings in a substantial fraction of winters. The Southern Hemisphere is almost the opposite arrangement. South of roughly 40 degrees latitude, the planet is mostly water, an uninterrupted belt of ocean circling the globe with very little land and no major mountain barriers to disturb the flow. Far fewer large waves are generated, so far less wave energy propagates upward, and the Antarctic vortex is left comparatively undisturbed to organise itself into a strong, symmetrical, tightly centred structure. That is why the Antarctic vortex is the stronger and more reliable of the two, and why major sudden stratospheric warmings in the Southern Hemisphere are genuinely rare events rather than a routine feature of the season. In the Arctic, they are close to expected. In the Antarctic, only a small handful of major disruptions have been documented across the entire satellite era, which tells you how significant it is that one occurred in 2024, and that it occurred earlier in the season than any previously observed. It also explains the shape of the temperature record. The reason every one of the coldest readings ever taken on this planet comes from the East Antarctic plateau is not only that the plateau is high and dry and dark, it is that the plateau is reliably sealed. The Arctic never manages that consistently, because its lid is being knocked about all winter by waves coming off the northern continents. The Antarctic lid most years holds. There is one further element in the Antarctic system that has no northern equivalent at anything like the same scale, and it is worth mentioning because it interacts with everything else. The stratosphere above Antarctica is where the ozone hole forms each spring, and ozone is not a passive passenger in this system. Ozone absorbs ultraviolet radiation and warms the air around it, so the amount of ozone present directly affects stratospheric temperature, which in turn affects the temperature gradient that drives the vortex winds. The relationship runs both ways, which is what makes it interesting. A colder, stronger, better sealed vortex promotes the chemistry that destroys ozone, because that chemistry requires the extremely cold clouds that only form inside a well-isolated vortex. Less ozone then means less absorbed ultraviolet, which means a colder stratosphere, which means a stronger vortex. That is a reinforcing loop, and it is one of the reasons this particular circulation can lock into an extreme state and stay there for weeks. So for a period of weeks, the lid over Antarctica was not just intact. It was as tightly sealed as this system gets, and the effect showed up exactly where you would expect it. Ensemble model guidance during that stretch had most of the Antarctic continent running more than 20 degrees Celsius below normal. Not one station, not one region. Most of the continent 20 degrees below its own already brutal winter baseline. That is the context for the reading at Concordia. It was not a fluke cold night at one base. It was the sharpest point of a continent-wide anomaly, produced by an unusually strong circulation, and Concordia recorded it, because Concordia is the place where all the amplifying factors stack. Now I want to add the detail that turns this from an Antarctic story into a global one, because on its own, an intense polar vortex chilling Antarctica is not surprising. It is what the vortex is for. The detail is position. The vortex is not a perfect circle centered neatly on the pole. It wanders. It has a core, a region where the circulation is strongest, and that core can sit over different sectors of the continent in different years. This year, through the period we are discussing, the core was strongest near and just west of the Amundsen Sea. That sounds like a technicality. It is not. It is the hinge of this entire story. The atmosphere is not made of independent local weather. It is made of waves, large-scale ripples in the flow, thousands of miles from crest to crest that wrap around the hemisphere. When you place a large, intense, low-pressure circulation in a particular spot, you do not just affect the air directly beneath it. You perturb the wave pattern downstream, and that perturbation propagates. A trough in one place forces a ridge somewhere else, which forces another trough further along, like a standing pattern in a river forced by a boulder on the bottom. The Amundsen Sea sector has a known downstream relationship with South America. A deep, intense vortex sitting there during the austral winter tends to induce a second trough off the central east coast of South America. That is a documented, repeatable configuration, not a novel claim. And the presence of that trough sets the temperature pattern for the southern half of the continent. In late June, that configuration was doing exactly what the textbook says. It was producing a cold pattern for Argentina, with a source region of cold air capable of surging north, far enough to threaten the coffee-growing regions of Brazil. Forecasters were watching it for precisely that reason. Then the wave pattern shifted phase. By the middle of July, the same wave train, driven by the same vortex, had swung into a configuration that was doing the opposite thing over that part of the continent. Forecast guidance issued around the 15th of July was calling for record warmth, centered on Paraguay and the surrounding region. 3 days later, Salta broke a 101-year-old record for its warmest night. That is the connection. Not a vague appeal to everything being connected, but a specific, traceable, physical chain. an unusually intense polar vortex sitting in a specific sector of the continent, isolating the plateau beneath it to the point of producing the coldest reading on Earth in 14 years, while simultaneously forcing a wave pattern downstream that delivered record heat to subtropical South America. One machine, two opposite outputs, same day. And once you see the atmosphere that way, a great deal of what looks like random contradiction starts resolving into structure. This is the thing I most want you to take from this video. When people say that record cold and record heat happening at the same time proves the whole field is confused, they are describing a real observation and drawing exactly the wrong conclusion from it. Simultaneous opposite extremes are not evidence that nobody understands the system. In a wave-driven atmosphere, they are the expected signature of a strongly amplified pattern. The peaks and the troughs of a wave are opposite by definition. They are also the same wave, which raises the obvious next question, and it is the one that occupied me longest while I was putting this together. If the lid holding produces the coldest air on the planet, what does the lid failing produce? We know the answer to that because it happened 2 winters ago. It was extraordinary, and it has since been studied and published in detail. But before we go there, I want to take you to Salta and show you exactly what that record night looked like in the data, because the shape of that anomaly tells you something about the wave that produced it, that the Antarctic side of the story cannot. Part 4. 7,000 miles north. Salta sits in the northwest of Argentina, in a valley in the foothills of the Andes, at an elevation of roughly 1,200 meters. It is a colonial city of a few 100,000 people, and for our purposes the important thing about it is that somebody has been writing down the temperature there every day since 1925. That is 101 years of observations, a century of Julys. In that century of Julys, the coldest month of the Salta year, the pattern is consistent and unremarkable. Nights get cold. The average daily minimum in the middle of winter sits at around 3 degrees Celsius. In some years it drops below freezing. If you plot every single day of every single year in that record on one chart, the winter section forms a dense band of cold nights, hundreds of overlapping lines, all of them low. On July 18th, 2026, the overnight minimum temperature at Salta did not fall below 26 degrees Celsius, 78.8 degrees Fahrenheit, as the low, overnight, in midwinter. The anomaly against the 1991 to 2020 reference period is plus 23.2 degrees Celsius, and I want to make sure that number registers properly, because temperature anomalies are the kind of statistic that slides past you. 23 degrees Celsius is roughly 42 degrees Fahrenheit. This was not a mild night. This was a night that behaved as though the city had been picked up and moved to a different latitude and a different season while nobody was looking. When that chart is drawn, the 2026 line does something visually violent. It tracks along with the rest of the century through autumn, dips into the winter band with everything else, sits down there among the coldest lines in the record in early July, and then in the space of about 72 hours it launches vertically off the top of the entire distribution, not to the upper edge of the historical range, past it, above every other line on the chart in the coldest week of the year, and then it falls straight back down again within days. The station itself is worth a sentence of description, because the identity of the instrument matters when a record this old is being broken. Salta Aero sits at an elevation of 1,221 meters, and carries the international identifier 87047. It is part of the global network of stations whose records are considered long and reliable enough to serve as reference points for climate assessment, which is precisely why a century of continuous observation exists there at all. The reference period used for the anomaly is 1991 to 2020. That is the current standard 30-year baseline used for this kind of comparison, and it is worth knowing that it is itself a relatively warm baseline by historical standards. Measured against an earlier reference period, the same night would have produced an even larger anomaly figure. That shape is important, so let me say what it tells us. A spike that sharp is not a warming trend. Nobody should look at that chart and see a slow signal. What that shape describes is an atmospheric event, a specific configuration that arrived, delivered an enormous slug of warm air over one region, and departed. In other words, it is exactly what a wave looks like when it swings hard. I should be straightforward with you about the sourcing here. This figure reached me the way a lot of extreme temperature records now travel, which is through the community of people who track climate records closely and publish charts built from official national data sets. The underlying data is from the Argentine National Meteorological Service, and the record series is theirs. What I have not seen is a formal bulletin from that agency confirming the record in an official statement. So take the specific claim as reported rather than as confirmed, and understand that on a fast-moving story that distinction matters. I would rather tell you where the number came from than pretend every figure arrives with a government seal on it. But here is why I have confidence that something real happened in northern Argentina that week, independent of the individual number. The forecast said so, 3 days in advance for structural reasons. Guidance issued around the 15th of July was already calling for record warmth centered on Paraguay and the surrounding region, which includes exactly this part of Argentina. That forecast was not built on some local quirk. It was built on the position of the wave pattern, which was itself being driven by the vortex configuration we have been discussing. The warmth was anticipated because the mechanism producing it was visible in the models before it arrived. That is what I mean when I say the two records are the same event. It is not that they rhyme. It is that one of them was predictable from the other's cause. Now the mechanism deserves a bit more explanation, because there is a step here that people often get wrong. When you hear that a trough sets up off the east coast of South America and produces a cold pattern, and then hear that the same region produced record heat, it sounds like a contradiction. It is not. It is geometry. A trough is a southward dip in the flow. On the western side of that dip, air is being drawn from the south, from the polar direction, and that brings cold. On the eastern side, air is being drawn from the north, from the tropical direction, and that brings warmth. The same feature delivers opposite outcomes depending on which flank of it you happen to be standing on. And because these wave patterns migrate and shift phase over weeks, a location that sat on the cold flank in June can find itself on the warm flank in July without the wave itself having done anything unusual. That is the flip that happened over southern South America between late June and the middle of July. The vortex kept doing what it was doing. The wave downstream of it swung. Argentina went from being fed cold polar air to being fed warm subtropical air, and in Salta that transition produced the warmest night in a century. Meanwhile, 7,000 miles south, nothing about the plateau changed at all, because the plateau does not sit on either flank of that wave. It sits underneath the lid, sealed off from all of it, cooling steadily in the dark. So on the 18th of July, one system was simultaneously producing the most extreme cold reading on Earth in 14 years and the most extreme warm night in a century of Argentine records through two entirely different parts of its own structure. I find that genuinely remarkable, and I think it is the most undercovered atmospheric story of this month. There is one more thing worth pulling out of the Salta number before we widen the frame, and it concerns which temperature broke the record. It was not the daytime high, it was the overnight low. Nighttime minimum records are the ones that tend to matter most for human beings, and this channel has come back to that point repeatedly through the heat coverage of this summer. The human body handles heat by shedding it, and the period when it does most of that work is at night, when the air finally cools enough for the process to run efficiently. When the night does not cool, the recovery does not happen, and the physiological stress accumulates across consecutive days rather than resetting each evening. A run of hot nights kills more people than a single hot afternoon. That is not the story in Salta, where a single warm winter night is a curiosity rather than a health emergency. But it is the reason meteorologists pay close attention to minimum temperature records specifically, and it is worth knowing that the record which fell that night is the category that carries the most weight. There is a connection here to something we covered about a week ago in the video on the record ocean temperatures, and it is worth making explicit because it is the same physical point arriving from a different direction. A warm night is a night when the air cannot shed its heat efficiently, and the single biggest control on that is how much moisture the air is carrying. Water vapour is what keeps the heat in after the sun goes down. So when the oceans run at their warmest June on record, at 20.98 degrees Celsius globally, the air masses that form over them and travel inland carry more moisture with them, and the nights underneath those air masses do not cool the way they used to. The daytime maximum is set largely by sunshine. The nighttime minimum is set largely by what is in the air, That is why minimum temperature records have been falling faster than maximum records in most parts of the world, and why the record that broke in Salta was the one it was. Salta is one city, though, and one city is an anecdote. What makes the 18th of July a genuinely strange date on the global calendar is what the rest of the planet was doing at the same time. Because while Antarctica was setting its coldest reading in 14 years, the Northern Hemisphere was in the middle of one of the most record-dense summers ever documented, and the gap between the hottest and coldest points on this planet had opened to a figure that I had to check 3 times before I believed it. Part 5. 136 degrees apart. 136.8 degrees Celsius. That is the distance between the hottest and the coldest temperatures measured anywhere on Earth so far in 2026. In Fahrenheit, it is roughly 246 degrees. To give that some shape, the entire span between the freezing point of water and its boiling point at sea level is 100 degrees Celsius. The temperature range this planet has produced this year is significantly wider than the gap between ice and steam. The cold end you already know, minus 84.1 at Concordia on the 18th of July. The hot end came from a meteor in Iran at 52.7 degrees Celsius. That is 126.9 Fahrenheit. 2 places on the same planet, breathing the same atmosphere, orbiting the same star, separated by a temperature difference larger than the full range of liquid water. And that spread is not the only thing 2026 has produced. More than 100 countries have reported record temperatures during this year. That is not 100 stations, 100 countries. Let me give you a few of the individual entries because the aggregate number is abstract and the specifics are not. 5 days before the reading at Concordia, the town of Armstrong in Ontario, Canada, reached 40.8 degrees Celsius. That is 105.4 Fahrenheit in the boreal forest belt of central Canada. It was the province's first 40-degree reading since 1995, and by most assessments its warmest temperature since the Dust Bowl years of the 1930s. In late June, Europe went through a heatwave that has since been associated with more than 10,000 excess deaths in the published data analysis. 10,000. That figure sits in this video as a single line, and it deserves to be sat with for a moment because the temperature records are the abstraction, and that number is what the abstraction costs. The world's oceans had their hottest June ever recorded, averaging 20.98 degrees Celsius across the global surface. Not one basin, the global ocean. And on the 21st of July, reports began circulating among the people who track climate records that Western China had gone through a record-breaking heat event, with 28 stations breaking or tying their July records and 4 stations setting all-time records. The highest figure cited in those reports was 49.8 degrees Celsius at Dongkan Station, in the Turpan Basin of Xinjiang, along with several other stations breaking records for their highest minimum temperature. I need to flag that last one carefully because I checked it, and I could not confirm it. Here is what I can confirm. Dongkan's verified record is 48.7 degrees Celsius, set on the 20th of July last year, and that reading stands as the 3rd highest temperature ever officially recorded at Chinese National Weather Station, behind 49.0 at Turpan and 48.8 at Toksan. China's national record is 50.3 degrees Celsius, measured near Ading Lake in Xinjiang in July of 2015. So a reading of 49.8 at Dongkan would be both a new station record and the 2nd highest official temperature in the history of Chinese observations. That is entirely plausible given what the rest of the region was doing, and it may well turn out to be correct. But it was not independently verifiable when I put this together, and I am not going to state it as fact on the strength of a social media post, however credible the account. This is a small thing, but I think it matters, and it connects directly to the argument I am going to deal with later in this video. If I want you to take seriously my rejection of a claim that gets circulated without verification, I have to hold the claims that support my own framing to exactly the same standard. Otherwise, I am just picking which unverified numbers I like. So, Western China was almost certainly extremely hot on the 21st of July, and the specific figure is unconfirmed. Now let me bring this back to the lid, because the global heat picture is not a separate topic from the Antarctic cold. It is the other half of the same measurement. The 136.8 degree spread exists because of 2 things happening at once. One end of it was produced by an unusually intense polar vortex sealing off a high, dry, dark plateau and letting it radiate toward the physical floor. The other end was produced by a Northern Hemisphere summer, running against a background that is measurably warmer than it used to be, with a global ocean at its highest recorded June temperature, feeding moisture and heat into the atmosphere above it. Those two things are not in tension with each other. They are not competing explanations. One is a circulation state, and the other is a background state, and they operate on different parts of the system. This is the distinction that I think gets lost more than any other in public arguments about temperature records, so I want to put it as plainly as I can. Circulation decides where the heat and cold go. Background decides what the heat and cold are measured against. A strong polar vortex will always produce extreme cold on the Antarctic plateau, in any climate, in any decade, because the physics of a sealed dark plateau does not care about the background. What the background determines is everything happening outside that seal. It determines how hot the warm flank of the wave gets when it swings over Argentina. It determines whether a heat wave in Europe kills 1,000 people or 10,000. It determines whether a hot June in the ocean is warm or unprecedented. And it determines something else that we will come to shortly, which is what happens on the day the seal fails. There is a symmetry at the hot end of this range that I promised earlier, and should now deliver, because it turns out that both ends of Earth's temperature record rest on measurements that people argue about. The highest temperature ever reliably recorded on this planet is generally given as 56.7 degrees Celsius, or 134 degrees Fahrenheit, measured at Furnace Creek in Death Valley, California, on the 10th of July, 1913. That reading has been disputed. The objections centre on the way the equipment was used, and the case against it has been made in enough detail that a number of climatologists no longer regard it as a valid record at all. If it were set aside, the highest reliably measured temperature on Earth would fall to a figure in the region of 54 degrees Celsius, recorded in more recent decades and under modern instrumentation. I raise it because it is the exact mirror of the point I made about the cold end. On the Antarctic plateau, satellite instruments have measured surface skin temperatures in small hollows, reaching somewhere between -93 and -98 degrees Celsius. Those are real numbers. They are also measurements of the temperature of the ice itself, taken remotely from orbit, rather than air temperatures taken at instrument height by a calibrated station. They do not replace the Vostok record, because they are not the same quantity. So on both ends of the range, the headline figure depends on a definition, and the definition exists for a reason. Records are comparisons across time, and a comparison is only meaningful if the thing being compared stayed the same. That is not a pedantic aside. It is the reason we can say anything at all about whether this July was unusual. Without a fixed standard, the reading from Concordia would just be a number with no context, and the argument that started around it the moment it appeared would be unresolvable in either direction. I want to give you one more comparison before we move on, because I think it is the cleanest way to hold both facts at once. Imagine a house in winter, with a fire in one room and a door to the outside standing open in another. You can walk from a room that is uncomfortably hot into a room that is freezing in the space of a few steps, and the size of that difference tells you almost nothing about whether the house as a whole is warming or cooling. To know that, you would have to measure the average across every room over time. What you can say is that the difference itself is a fact about how the house is arranged. It tells you the doors are open in specific places. That is what a 136-degree spread is. It is a statement about the arrangement of the atmosphere in July of 2026 and about how strongly that arrangement is currently amplified. It is not a statement about the average in either direction, and anyone using it as one from either side of the argument is using it wrong. Now, I have been describing the lid as something that either holds or fails, and so far this entire video has been about the holding case. There is a reason I keep gesturing at the other one. 2 winters ago, over this same continent, the lid did not hold. What happened next was documented in detail, published this April in a peer-reviewed journal, and it produced numbers that are, in their own way, considerably more alarming than -84. But before we get there, I have to show you something that happened on the Antarctic Peninsula 6 weeks ago, because it is the piece of evidence that convinced me this is not a story about one cold reading at all. Part 6. The continent broke a heat record too. On the 6th of June 2026, Esperanza Base recorded 15.4 degrees Celsius. Esperanza is an Argentine station on the northern tip of the Trinity Peninsula, the finger of land that reaches up from West Antarctica towards South America, 15.4 degrees Celsius is roughly 60 degrees Fahrenheit. It was a winter record for the station, 60 degrees Fahrenheit, in Antarctica. In June, which in the Southern Hemisphere is the equivalent of December. Other research stations in that region logged similar record warmth in the same stretch, and the temperature did not spike for an afternoon and retreat. For nearly 3 straight weeks, daily maximum temperatures in that part of the peninsula stayed above freezing. 3 weeks of thaw, in the dark half of the year. The consequence showed up on the ice. The melting was severe enough that bare ground appeared at the mountain bases of the Collins Glacier. Rock, exposed in midwinter on a glacier in Antarctica. 6 weeks later and roughly 2,000 miles away, on the other side of the same continent, the air fell to within 5 degrees of the lowest temperature ever recorded on this planet. I said at the start that when I first put those 2 data points beside each other, I assumed I'd made a mistake. This is the pair I meant. Same continent, same winter, one end setting a record for heat and melt, the other setting the coldest reading on Earth in 14 years. And I want to be precise about why that combination is the thing that reframes this entire story, rather than just being a fun piece of trivia. If Antarctica had only produced the cold record, you could tell a simple story about an unusually strong vortex and leave it there. A cold winter in a cold place. If it had only produced the peninsular warmth, you could tell an equally simple story about a warming continent. Neither of those stories survives the other one existing. What survives is the version I have been building toward. The continent is not simply cold, and it is not simply warming. It is running an enormous and increasing spread between its own extremes, and the thing determining which extreme shows up in which place is the state and position of the circulation overhead. The peninsula is the clearest illustration of that because of where it sits. The Trinity Peninsula reaches north of the main body of the continent, out past the edge of the vortex into the belt of ocean and storm systems that circle the Southern Ocean. It is the one part of Antarctica that is not fully under the lid. When the vortex is tight and the flow around it is strong, that flow can drive warm, moist maritime air directly onto the peninsula, while the interior stays sealed and freezing. So the same intense circulation that was quarantining the plateau was, on its outer flank, running a conveyor of relatively warm ocean air over the one piece of Antarctica that sticks out into it. The peninsula was not warm despite the strong vortex. It was arguably warm partly because of it. That is the shape of this whole system, and it is why I keep coming back to the wave framing. Strong amplification does not make everything cold or everything warm. It makes everything more different from everything else. There is a second reason the peninsula matters more than the plateau, and it is the reason this section is not just a curiosity. It is about what the ice is doing there. Concordia sits on roughly 2 miles of ice at 10,000 feet, in a place where a 30-degree warm anomaly would still leave the temperature far below freezing. Nothing melts at Concordia when it gets warm. It simply gets less absurdly cold. The plateau ice is not going anywhere on any timescale that concerns anyone alive today, and I want to be honest about that rather than imply otherwise. The peninsula is a completely different situation. That is low elevation ice, sitting at latitudes where the temperature is already close to the melting point for parts of the year, adjacent to an ocean that delivers heat from below as well as above. That is ice that responds. That is ice where 3 weeks above freezing in midwinter produces bare rock at the base of a glacier. So when I talk later in this video about the lid failing at the wrong moment, this is the geography I mean. Not the interior, where a temperature record is a temperature record. The margins, where a temperature record is a melting event. I should note the honest counterweight here as well, because I do not want to build a one-sided case. Antarctic sea ice this year has not behaved the way a straightforward collapse narrative would require. The annual minimum, which occurred on the 26th of February, came in at 2.58 million square kilometres. That ranks 16th lowest in the 48-year satellite record. 16th lowest is genuinely low, and it sits 260,000 square kilometres below the 1981 to 2010 average, so nobody should call it healthy. But it was also a significant recovery from the previous 4 years, which was severe enough that researchers had begun asking whether the system had shifted into a new state. This year, at the minimum, it partly came back. It is worth being specific about what the sea ice numbers describe, because sea ice and ice sheet are 2 entirely different things, and the distinction gets blurred constantly. Sea ice is frozen ocean. It forms in autumn, expands through winter to a maximum around September, and retreats through summer to a minimum in February. It floats, which means its melting adds nothing directly to sea level, in the same way that a melting ice cube does not raise the level of a glass. What it does affect is albedo, since bright ice reflects sunlight that dark water absorbs, and it affects the exchange of heat and moisture between ocean and atmosphere, and it acts as a physical barrier protecting the floating ice shelves at the continent's edge from ocean swell. The ice sheet is the ice sitting on land. That is the 2 miles of accumulated snow beneath Concordia and the vast volume behind the coastal margins. That ice is what raises sea level when it reaches the ocean, and the ice shelves that float out from it act as buttresses, slowing the flow of the glaciers behind them. So when I say that this year's sea ice figures do not support a collapse narrative, I am making a narrow statement about the floating ocean ice, and it does not translate into a claim about the ice sheet. The other reason the sea ice number matters here is the one raised in the 2024 study, and it connects directly back to the lid. That study noted that the 2024 heatwave likely contributed to persistently low sea ice off the affected sector, and that this contributed to the second lowest annual maximum extent in the satellite era, following the record low of 2023. I include that because it complicates the picture, and complications belong in the video rather than on the cutting room floor. The sea ice signal in 2026 does not support a story of runaway collapse. It supports a story of a system with very large swings, which is, as it happens, exactly the story the temperature data is telling as well. There is one more link in this chain that I want to plant now and return to later, because it is the piece that ties the ice back to the lid. The research on the 2024 event, which we are about to get to in detail, raises the possibility that reduced sea ice may itself make the vortex easier to break. The proposed mechanism is that less sea ice weakens the temperature contrast at the surface between the continent and the ocean, and that this alters the way large atmospheric waves propagate upward from the lower atmosphere into the stratosphere, where they are the very things that disrupt the vortex. If that is right, then the ice and the lid are not two separate topics at all. Less ice makes the lid more fragile. A broken lid drives warm air onto the margins. Warm air on the margins costs you more ice. I want to be careful here, because that is a proposed feedback and not an established one. The authors of that study raise it and then say directly that quantifying it remains limited by current observational and modelling constraints. It is a live research question, not a finding. But it is the kind of loop that, if it turns out to be real, changes how you read every number in this video. For now, hold it as an open thread rather than a conclusion, because the thing I have been promising you for the last hour is the case where this lid, the same structure that produced minus 84.1, came apart entirely. It happened in 2024. It broke a record that had stood for the entire satellite era. And the study that examined it did something that most extreme weather coverage never gets to do, which is put a number on how much of it was us. Part 7. 2 winters ago, the lid broke. In early July of 2024, the Antarctic stratosphere did something it had never been observed doing that early in the year. It warmed, suddenly and dramatically, and out of season. The phenomenon is called a sudden stratospheric warming, and the name is a plain description of what happens. Temperatures high above the pole climb sharply over a matter of days, sometimes by tens of degrees, and the polar vortex responds by slowing down, stretching, wobbling off centre, or in the most extreme cases collapsing entirely. 2 of those events occurred in succession in early July 2024. It was the earliest sudden stratospheric warming ever recorded in the Southern Hemisphere since satellite observation began in 1979. The lid came apart at the beginning of winter rather than the end of it. What happened underneath was, in the language of the study that examined it, the most intense winter heatwave in the 46-year satellite era. The region affected was Dronning Maud Land, a vast sector of East Antarctica facing the Atlantic. From the 24th of July to the 9th of August, regional average surface air temperatures across that sector ran more than 9 degrees Celsius above the climatological mean for 17 consecutive days. 17 days. 9 degrees above normal, averaged across an entire region of a continent. The peak values were considerably higher than the average. In central Dronning, Maud Land on the 5th of August, near surface temperature anomalies reached 27.5 degrees Celsius. At two individual stations, Relay and Dome Fuji, the anomalies on that same day peaked at 30.1 and 30.9 degrees Celsius respectively. 30 degrees Celsius above normal in Antarctica in August, which is the depth of winter there. To put that in the terms this video has been using, the same continent that produced minus 84.1 this July produced a plus 31 degree anomaly 2 winters ago. The lid held, and you got the coldest air on Earth. The lid failed, and you got the largest winter temperature departures the satellite record contains. The statistics on how unusual that was are worth stating precisely. The study estimated a return period of approximately 1 in 135 years for an event of that magnitude. The regional temperature exceeded 3 standard deviations from the mean, and the associated precipitation exceeded 4 standard deviations. Both were the most extreme values in the reanalysis record going back to the start of the satellite era. Now, how does a broken lid make a continent hot? The mechanism turns out to be a chain of steps, and each one is worth understanding because they are the same steps in reverse that produced Concordia. The weakened vortex allowed a large high-pressure anomaly to establish itself over the region. That high-pressure feature, which the authors describe as quasi-barotropic, meaning it extended coherently through the depth of the atmosphere, rather than being confined to one layer, acted as a block. Instead of the flow running west to east around the continent, it was forced to bend poleward, and it carried heat and moisture with it straight in from the middle latitudes. That transport of warm, moist air from the north accounted for approximately half of the observed surface warming. Circulation alone, by the study's separate analysis, accounted for 47% of the total anomaly. Then a second effect stacked on top of the first. The moisture arriving with that air, delivered in part by a series of atmospheric rivers, raised the humidity in the lower atmosphere and increased cloud cover over the region. And here we come back to the physics from earlier in this video, running in the opposite direction. Remember what makes Concordia so cold? Dry air, no clouds, nothing to send the escaping heat back down. The plateau radiates and loses. Put water vapor and cloud over that same surface, and you invert the whole arrangement. Now there is something in the air absorbing the outgoing infrared and sending a portion of it back to the ice. The study calls this a water vapor, cloud and radiation feedback, and it reinforced the surface warming that the wind had already delivered. So the sequence runs, the lid weakens, a blocking high forms, warm moist air pours in, the moisture and cloud then trap heat at the surface, and the anomaly amplifies itself. There is one more piece, and it is the part that pushes this out of Antarctica entirely. What broke the vortex in the first place? The study traces it back to atmospheric waves. Specifically, the vertical flux of wave energy from the lower atmosphere into the stratosphere spiked. The measurement they use for this, the eddy heat flux at the 10 hectopascal level across the band from 45 to 75 degrees south, exceeded 4 standard deviations, and it was dominated by the very largest scale of wave, the one that wraps once around the hemisphere. Before I answer that, the measurement itself deserves a moment, because it is the piece of evidence that makes the whole chain more than a story. The quantity the researchers used to track this is called the eddy heat flux, and despite the name, it is a fairly intuitive thing. It measures how much heat is being carried poleward by waves in the atmosphere, as opposed to by the steady average flow. When large waves are propagating upward and poleward with vigour, that number climbs. It is one of the standard diagnostics for whether a polar vortex is about to be disturbed, because wave activity is the mechanism by which vortices get disturbed. In the run-up to the 2024 event, the eddy heat flux at the 10 hectopascal level, measured across the band from 45 to 75 degrees south, exceeded 4 standard deviations from normal. 4 standard deviations is an extraordinary excursion for an atmospheric quantity, and it was dominated by what atmospheric scientists call zonal wave number 1, which describes a wave with a single crest and a single trough wrapping once around the entire hemisphere. That is the largest scale of wave the planet can host. The researchers also tracked the related quantity called the Eliason-Palm flux, which describes the vertical propagation of wave activity from the lower atmosphere into the stratosphere. It too showed strong upward transmission, coinciding with a reduction in the zonal winds and preconditioning the vortex for what followed. So the sequence has a clear order. Wave activity spikes and propagates upward. The winds of the vortex slow, the structure destabilizes, The stratosphere warmed suddenly, and the lid, which had been sealing off a continent, stopped sealing. And where did those waves come from? Enhanced convection east of Australia. Wave trains propagating poleward from South America and the subtropical Atlantic. Thunderstorms in the tropics and the subtropics, thousands of miles away, pumped energy upward and poleward, and that energy travelled into the Antarctic stratosphere and broke the lid. I find that one of the more remarkable statements in the paper, and it is easy to skim past. The circulation that determines whether the coldest place on Earth reaches -84 or +30 is being pushed around by weather systems in the tropics. This is not a self-contained Antarctic system. It is the far end of a chain that starts in warm ocean water halfway around the planet, which is, incidentally, why I flagged the El Niño question earlier and then declined to make a claim about it. Tropical forcing does influence the wave trains that reach the stratosphere. That is established. Whether this particular El Niño, currently strengthening through 2026, has anything to do with this particular vortex state is not established, and nobody has published an attribution linking them. So I will say what is known and stop where the knowledge stops. There is one line in the paper that I have been holding back, and it is the most important sentence in it for our purposes. For all the drama of a 30-degree anomaly, the authors note plainly that during the 2024 heatwave, most surface temperatures remained well below the melting point. Read that carefully, because it cuts both ways. On one hand, it is a caution against overstating what happened. The most extreme Antarctic winter heatwave in the satellite record did not melt East Antarctica. It made a brutally cold place merely very cold. The ice sheet was not in danger. On the other hand, it tells you exactly what the threshold is that we are watching for. The reason a 30-degree anomaly over Dronningmord Land is a temperature story rather than a sea level story is that the starting point was so far below freezing that even an enormous departure did not reach zero. That safety margin is a property of the interior. It is not a property of the whole continent, and 6 weeks ago on the peninsula, 3 straight weeks of daily maxima above freezing produced bare ground at the base of a glacier. So the question that the 2024 event leaves behind is not whether the lid can fail. We know it can. It is what happens the year it fails over the part of Antarctica where the margin has already run out. Before I can put that question properly, though, there is a number in that study that I have not given you yet, and it is the one that turns this from a weather story into something else. Because the researchers did not stop at describing what happened, they asked how much of it was ours. Part 8, 0.7 degrees. The study was published on the 1st of April 2026 in a journal called NPJ Climate and Atmospheric Science. The title is a fairly complete summary of the findings on its own. Unprecedented 2024 East Antarctic winter heatwave driven by polar vortex weakening and amplified by anthropogenic warming. The author list is long and includes researchers working on Antarctic meteorology, stratospheric dynamics, and extreme event attribution across a number of institutions. The lead authors are Hao Sutang and Sihan Li, and the list includes Julie Jones, Sergi Gonzalez Herrero, Andrew Orr, Friederike Otto, James Screen, Kyle Clem, Dennis Boskert, Jennifer Cato, Charlie Sweeters and Michelle McLennan, among others. Attribution science is worth explaining briefly because it is often described badly, and the criticism it attracts usually targets a version of it that does not exist. The question attribution asks is not whether a given event was caused by human activity. That framing is a category error, and researchers in the field say so constantly. Weather events have proximate causes, and the proximate cause of the 2024 heatwave was a broken polar vortex, not a factory. The question attribution actually asks is a comparative one. You take the world as it is, with the greenhouse gas concentrations we have added, and you run the physics. Then you construct a world without that addition, run the same physics, and compare. You're asking two things. How much more intense was this event in the world we live in than it would have been in the other one, and how much more likely? For the 2024 East Antarctic heatwave, the answers were as follows. Human-caused warming intensified the event by approximately 0.7 degrees Celsius, and more than doubled the likelihood of an exceptional winter heatwave of that kind. The probability ratio came out at 2.6. 0.7 degrees on an event whose peak anomaly was 30.9 might sound like a footnote. It is not, and the reason is the way probability behaves at the tail of a distribution. When you shift an entire distribution slightly warmer, the change in the middle is small, and the change at the extreme edge is large, because the edge is where the distribution is thinnest. A modest shift in the background moves a huge fraction of the low probability tail across whatever threshold you are measuring. The study puts the consequence in a sentence I think is the clearest framing of the whole paper. What would have been a multi-century heatwave under natural forcing has become a centennial-scale event in the present-day climate. Then they looked forward, and this is where the numbers get uncomfortable. Relative to a climate with no human influence, the likelihood of an event like this rises from the 2 to 3 times it sits at today, to roughly 6 times under a moderate emissions pathway by the end of the century, and up to 26 times under a high emissions pathway. In terms of return periods, the projections have this kind of event falling from something you would expect roughly once every 200 years in the natural world, to something like once every 50 years under moderate emissions and once every 10 years under the high emissions case. Once a decade, an event that broke the entire satellite record. It is worth seeing how those headline figures were arrived at, because the study did not use a single method. It used several, deliberately, and then compared them, which is the standard approach in this field precisely because no individual method is trusted on its own. One approach ran a large ensemble of climate model simulations, 525 members in each of 2 configurations, one representing the world as it is, and one representing a world with only natural forcing. In the natural world configuration, an event of this magnitude occurred in 0.7% of simulated cases. In the configuration including human influence, it occurred in 1.9%. That is a probability ratio of 2.9, and it corresponds to the return period falling from roughly 200 years to roughly 70. The associated magnitude shift in that method was 1.1 degrees Celsius. A second approach used a different family of models and found the likelihood rising from 0.2% to 0.4%, a probability ratio of 2.2, with a magnitude shift of roughly 0.6 degrees. A third approach did not use models to generate the event at all. Instead, it searched the observational record for days when the atmospheric circulation looked similar to the days of the heat wave, and then compared how warm those analog days were in the earlier part of the record against the later part. That method found the typical temperature anomaly on analog days rising from 2.2 degrees Celsius in the earlier period to 3.9 degrees in the more recent one. Same circulation, warmer outcome. That is the cleanest demonstration in the entire paper of the point I have been making, because it holds the dynamics fixed by construction and measures only what the background contributed. A fourth approach took the actual event and re-ran it in a high-resolution regional model under 2 different background states, and found the version in the cooler background producing an anomaly roughly 0.3 degrees lower. The 0.7 degree figure and the probability ratio of 2.6 are the unweighted averages across those methods, which is why the authors are careful to describe them as indicative central estimates rather than a formally combined result. Now, I promised earlier that I would hold my own sources to the standard I am asking of everyone else, so let me give you the caveats the authors themselves put in print, because they are substantial and they were not hidden. The synthesized attribution figures, they say, should be interpreted as indicative central estimates rather than formally combined metrics, because averaging across different methods does not properly account for the ways those methods depend on one another. The uncertainty intervals on several of the individual estimates are wide, and some of them cross zero, which means those particular methods could not rule out no effect at all. The authors attribute that width primarily to the pronounced internal variability of the Antarctic climate, which is a polite way of saying that this region swings so hard on its own that separating a signal from the noise is genuinely difficult. They also state that one of their modelling approaches should be read as a set of sensitivity experiments conditioned on a given circulation pattern, rather than as a quantitative estimate of how likely the event was. And there is one more finding that cuts against the simplest reading of the whole paper, which I think is the most intellectually honest thing in it. When they looked for a trend in how often the circulation pattern that caused this event actually occurs, they did not find one. Neither the reanalysis record nor the model simulations showed a robust or statistically significant long-term trend in the frequency of 2024-style circulation patterns over the satellite era. Sit with that for a moment, because it is the key to reading this correctly. The dynamics are not obviously changing, The frequency of the vortex breaking down in this particular way does not show a clear trend. What has changed is the temperature of the world that those unchanged dynamics operate in. So when the pattern occurs, and it occurs about as often as it always did, it now delivers a hotter outcome, and that hotter outcome crosses thresholds that the older version of the same pattern did not reach. This is the version of the argument I said I would carry, and now you can see why it is more interesting than the simple one. Nobody needs to claim that the atmosphere is behaving strangely, or that the circulation has been altered, or that the vortex is failing more often. The claim is narrower and better supported. The same machine, running the same way against a warmer background, produces records it did not use to produce. And it runs in both directions, which is the part almost nobody says out loud. A warmer background does not stop the vortex from locking down and producing extreme cold on the plateau. The physics of a sealed, dark, dry plateau radiating to space is not affected by the concentration of carbon dioxide in any way that shows up over a few decades at those temperatures, so we should expect exactly what we're seeing: near record cold when the lid holds, record-shattering warmth when it fails, the cold end barely moving and the warm end moving a lot, which produces a signature that looks, to anyone reading the headlines rather than the mechanism, like total contradiction. Coldest temperature on Earth in 14 years, hottest June ever recorded in the global ocean. Both true, both in the same year, both, in a sense, expected. That contradiction is not an accident of coverage, it is the shape of the thing, and it is the reason the number from Concordia has spent the last several days doing work in an argument that has very little to do with Antarctica, which is where I want to go next, because I have been promising it since the first 10 minutes, and because I think the honest version of that argument deserves better than the treatment it usually gets. Part 9. The argument this record started. Within hours of the Concordia figure appearing, it had been picked up and turned into an argument, and the argument was not about Antarctica. The claim is simple and it travels fast. The coldest temperature in 14 years has just been recorded. So much for the warming crisis. In at least one prominent packaging that I saw, the reading was bundled directly alongside political stories about official climate documents being reviewed for alleged fraud, which tells you what the number was being used for. I want to take this seriously rather than sneer at it, for two reasons. The first is that sneering has never once changed anybody's mind about anything. The second, and more important, is that there is a piece of this complaint that is legitimate, and pretending otherwise is how you lose the people who might otherwise listen. So let me give you the legitimate piece first. Cold records still happen in a warming world. That is not a concession, it is a straightforward consequence of the physics I have spent this video describing. Circulation still produces extremes. Sealed dark plateaus still radiate to space. Nothing about a warming background stops the Antarctic vortex from locking down and delivering an extraordinary cold reading, and anyone whose communication implies that cold records should have stopped by now has taught the audience something false. And here is the part that I think genuinely frustrates people, which I have not often heard acknowledged. There is an asymmetry in coverage. Heat records get reported prominently and cold records get reported quietly, or not at all, or with an explanatory framing that heat records rarely receive. People notice that. They are not imagining it. When you only ever see one direction of extreme reported as significant, and you know from ordinary experience that cold snaps still exist, it is entirely rational to conclude that you are being shown a curated slice of the data. That is a real grievance about science communication, and it deserves an honest answer rather than a dismissal. The honest answer is that the asymmetry in coverage is real, and the conclusion drawn from it is wrong. Both of those things can be true at once, and in this case they are. So here is why the conclusion does not survive contact with the number itself. Minus 84.1 degrees Celsius is not the coldest temperature ever recorded on Earth. The record is minus 89.2, set at Vostok Station on the 21st of July 1983. This reading missed that mark by 5.1 degrees. Think about what it would take for a cold record to be evidence of a cooling planet. You would want a new all-time low. What we have instead is a reading that falls more than 5 degrees short of a mark set 43 years ago, in a decade when the world was measurably cooler than it is now. If the planet were cooling, the coldest place on it should be setting new records, not falling short of a mark from the Reagan administration. Second, consider what the phrase coldest since 2012 actually describes. It is a statement about one station in polar night on one day over a 14-year window. It is not a statement about the Antarctic continent or the Southern Hemisphere or the global mean. It is a single-point observation, and single-point observations are weather. The global mean is a different quantity, measured differently, and this year that quantity has been doing something quite specific. Over 100 countries have reported record temperatures in 2026. The global ocean recorded its hottest June ever measured at 20.98 degrees Celsius across the surface. A late June heatwave in Europe was associated with more than 10,000 excess deaths. You do not get to take one station's 14-year cold record as the global signal and dismiss the ocean, which covers 70% of the planet, as noise. If single readings count, the reading from a media at 52.7 degrees Celsius counts too, and that one is on the other side of the ledger. Third, and this is the argument that I find most decisive, the mechanism that produced this cold record is the same mechanism whose failure produced the 2024 heat record, and that heat record has a peer-reviewed human attribution attached to it. You cannot cite the polar vortex when it delivers cold and ignore it when it delivers heat. It is one structure. If its behavior this July is meaningful, its behavior in 2024 is meaningful too, and the published analysis of that behavior found human warming intensified the event and more than doubled its likelihood. There is one more piece of arithmetic worth doing here, because it settles the question in a way that does not depend on trusting anybody's model. The Vostok record was set in 1983. In the 4 decades since, the planet's average surface temperature has risen by something on the order of 0.8 of a degree Celsius. If a warming background were being contradicted by this July's reading, you would expect the reading to be at or below the 1983 mark. Instead, it came in 5.1 degrees above it. Now, I would not claim that the gap between those two numbers is a measurement of global warming, because it is not. The difference between two individual cold extremes 43 years apart is dominated by circulation, not by background, and I have spent this entire video explaining why. Vostok in 1983 presumably had its own exceptionally locked-down vortex, and the specific conditions of any single day are effectively noise. But that cuts both ways, and that is the point. If the gap cannot be used as evidence of warming, it cannot be used as evidence against it either. A single station's cold reading is a statement about the circulation over that station on that day, and nothing more. Anybody presenting it as a verdict on the global temperature record is making a claim the data cannot support regardless of which conclusion they are reaching for. The quantity that can speak to the global question is the global one, and it is measured across the whole surface over years, with the seasonal cycle removed. That quantity is what it is, and one thermometer on the East Antarctic plateau does not move it. There is a related claim that I want to address separately, because it is subtly different and it comes up constantly. That claim is that the cold data is being suppressed. The response here is almost too easy, and I say that with some sympathy. The Concordia reading came from the monitoring network itself. It was published, as it always is, by the same institutions that publish everything else from that network. Mainstream weather outlets reported it within about a day, several of them leading with the contrast between the Antarctic cold and the Northern Hemisphere heat as their headline. The data was not hidden. It was measured by a government-funded research station, transmitted through an international observation network, and reported by ordinary weather media inside of 24 hours. What is true is that it did not receive the same volume of coverage that a comparable heat record would have. That is an editorial pattern, not a suppression campaign, and the distinction between those two things is the difference between a criticism worth making and a conspiracy that falls apart on inspection. I would go further, actually. I think the way this particular number was covered was mostly good. Several outlets ran it precisely as what it is, which is a striking contrast between the two ends of the planet's temperature range in the same week. The 136.8 degree spread was itself the headline in more than one place. That is not suppression. That is the story being told correctly. It is worth adding one observation about how these arguments actually get built, because I think it is the most useful thing anybody can take away from a story like this. Notice that the claim being made about the Concordia reading requires you to accept a single station's measurement as globally meaningful, while simultaneously rejecting the aggregated global measurements as unreliable. Those two positions cannot both be held at once. Either individual station readings are good evidence, in which case Omidyar at 52.7 and Armstrong at 40.8, and the 100-plus countries with records are evidence too, or they are not, in which case Concordia is not either. The same test applies to my side of it. I do not get to cite the 2024 attribution study while waving away its uncertainty intervals, and I do not get to treat the Salta figure as gospel when I have already told you it arrived without an agency bulletin behind it. Consistency is not a rhetorical nicety here. It is the only thing that lets anybody sort a real signal from a preferred one. There is a broader version of the complaint that I do have time for, though, and it is this. If you only tell people about the heat, you leave them completely unequipped for the moment when the cold arrives. And the cold will arrive, repeatedly, for as long as the circulation exists. Every time a cold record lands on an audience that was implicitly taught cold records had ended, the credibility of everything else takes damage. The way through that is not to stop reporting the cold. It is to explain the machine, so that a cold record and a heat record from the same season stop looking like two people arguing and start looking like what they are, which is one system with a wide swing. That is the entire purpose of this video, and it is why I opened with the two numbers together rather than picking whichever one made a better thumbnail. There are two other explanations that get offered for events like this, and both of them are easier to close out than the first one, so let me deal with them before we return to the ice. Part 10. What the Sun was not doing. Whenever anything unusual happens in the atmosphere, one of the first explanations offered is that the Sun did it. I have a certain amount of patience for this, more than most people covering this material, because the Sun genuinely does drive an enormous amount of what happens on this planet, and because this channel spends a great deal of its time on solar activity for exactly that reason. Asking whether the Sun is involved is a reasonable question to ask first. In this case, the answer is unusually clean, and it is no. Here is the state of the Sun during the period we have been discussing. The sunspot number for June of this year was 94.4, which is down more than 20 compared to the same month a year earlier. Solar cycle 25 is in its declining phase, past its maximum, on the long slope down toward the next minimum. Activity is moderate and falling. Geomagnetic conditions around the 18th to the 21st of July were quiet. The NOAA scales that describe geomagnetic storming, solar radiation storms and radio blackouts were all sitting at 0 on the day this video was produced. A minor geomagnetic storm was forecast for the 22nd, driven by a stream of fast solar wind from a coronal hole, which is an ordinary and recurrent feature of the declining phase, so the Sun was doing nothing remarkable while both of these records were being set. But quiet conditions are not really the argument. The argument is mechanism, and there is no plausible one here. To connect solar activity to what we have been describing, you would need a pathway by which the state of the Sun produces an Antarctic Oscillation Index of plus 5.0, positions a vortex core near the Amundsen Sea, and delivers a record warm night to a valley city in northwestern Argentina on a specific date. No such pathway exists in the literature, and nobody has proposed a serious one. There is a real and well-studied solar influence on the stratosphere, and I want to acknowledge it so that I am not overstating my case. Variation in ultraviolet output across the solar cycle does affect stratospheric ozone and temperature, and there is legitimate research on how that influence propagates into circulation patterns. That effect is real. It is also small, slow, and operates across the 11-year cycle rather than across the 4 days between one record and another. Nothing about a declining sunspot number explains a plus 5.0 circulation index in one specific winter. The second explanation that circulates whenever a pattern looks strange is that the pattern was engineered. Weather modification, geoengineering, and the perennial favourite, that particular array of radio antennas in Alaska. This one comes down to a scale comparison, and once you run the comparison it is finished. The Antarctic Stratospheric Polar Vortex is a hemispheric scale circulation. It is a ring of 200-mile-an-hour winds, tens of miles up, encircling a continent roughly the size of the United States and Mexico combined. The energy involved in establishing, maintaining and disrupting that structure comes from the temperature gradient between the pole and the equator, which is ultimately powered by the difference in sunlight received at different latitudes and from planetary scale waves generated by weather systems across an entire hemisphere. We covered the source of those waves in the 2024 case, convection east of Australia, wave trains from South America, and the subtropical Atlantic. Thunderstorm complexes over tropical ocean, thousands of miles from the pole pumping energy upward. Human beings do not have a technology that operates at that scale, not close. The total energy involved in the disruption of a polar vortex exceeds the entire annual electricity generation of human civilization by orders of magnitude, and it is delivered by a mechanism, tropical convection, that we can observe directly with satellites and that nobody controls. The honest version of the weather modification conversation is much narrower and much more boring than the version that travels. Cloud seeding is real, it is licensed and practiced in many places, and under the right conditions it can nudge precipitation from a cloud that was already going to produce some. That is the scale of what humans can currently do to weather. Nudging existing clouds slightly. It is a very long way from moving a stratospheric vortex. There is a related idea that shows up whenever this kind of number appears, which is that the temperature data itself has been adjusted, corrected, homogenized, or otherwise manipulated into telling the story somebody wanted. Adjustment is real, and this is another case where the honest answer is more interesting than either the accusation or the flat denial. Temperature records do get adjusted routinely and openly, and there are good reasons for it. Stations get relocated, instruments get replaced with different models that read slightly differently. Observation times change. A town grows up around a site that used to be in a field. If you want to compare a reading from 1983 with a reading from 2026, you have to account for the ways the measurement itself changed in between, or you are comparing two different things and calling the difference climate. What makes this checkable rather than a matter of faith is that the adjustments are published, the methods are documented, and independent groups using independent methods on overlapping data arrive at closely similar answers. Several of those groups were set up specifically by people who expected to find a problem and did not. None of which is relevant to the Concordia reading anyway, since a single current observation from an operating station requires no homogenization at all. It is simply what the instrument recorded. The third explanation, and this one comes from a different direction entirely, is that a record cold reading signals the beginning of a cooling period, or an ice age, or the flip of something fundamental. I want to close this one out with the same even-handedness, because the overreach here runs in both directions, and I have seen both this week. A strong polar vortex year is variability. It is the system doing what the system does at the strong end of its range. It is not a regime change, it is not a trend, and one winter's circulation index tells you nothing about the following decade. Every few years the vortex locks down hard, and when it does, the plateau gets extraordinarily cold. That is normal. And on the other side, the ice data this year does not support a collapse narrative either. I mentioned this earlier, and it bears repeating in this context, because it is the kind of inconvenient fact that gets left out by whichever side finds it awkward. The Antarctic sea ice minimum in February came in 16th lowest in a 48-year record, a meaningful recovery from 4 consecutive severe years, while still sitting 260,000 square kilometres below the long-term average. That is neither a collapse nor a recovery to health. It is a system that swung down hard for 4 years and then partly swung back, which is exactly the kind of behaviour you would expect from a system whose variability is large. Both of the confident readings are wrong for the same reason. They take a wide swinging system, grab one data point from whichever end suits the argument, and extrapolate a direction from it. There is one genuinely open question I want to put in front of you rather than answer, because it is the kind of thing this channel should be honest about not knowing. The tropical Pacific is currently in an El Niño state, and a strengthening one. The most recent index value put the ocean temperature anomaly at plus 0.98 degrees Celsius, which is a substantial swing from the La Niña conditions of just over a year ago, and forecast through the back half of this year point toward further strengthening. Now recall the finding from the 2024 study about where the waves came from that broke the vortex. Convection east of Australia, wave trains propagating from South America and the subtropical Atlantic. Tropical thunderstorm activity, in other words, pumping energy poleward and upward. El Niño rearranges tropical convection. That is essentially what El Niño is, at the mechanical level, a redistribution of where the warmest water sits and therefore where the biggest thunderstorm complexes form. So there is an obvious hypothesis available, which is that the state of the tropical Pacific influences the wave forcing that determines whether the Antarctic vortex holds or breaks. I want to be clear that this is a hypothesis I am describing, not a finding I am reporting. There is legitimate published research on tropical influences on the Southern Hemisphere stratosphere. There is no attribution study linking this specific El Niño to this specific vortex state, and I have not seen anyone credible claim there is. If somebody tells you confidently that El Niño caused the coldest reading on Earth in 14 years, they are ahead of the evidence. What I will say is that if the vortex does break before spring, the question of whether the tropics had a hand in it will be one of the first things researchers look at. The pattern I keep coming back to, and the one that I think actually holds up, is narrower and stranger than either. Antarctica this year gave us a near-record cold reading on the plateau and a record melt event on the peninsula in the same winter 6 weeks apart. 2 winters ago it gave us the most intense winter heatwave in the satellite record. The machine that decides which of those things happens is the lid, and the lid is being pushed around by weather in the tropics. None of that is a story about the sun, none of it is a story about engineering, and none of it is a story about the planet cooling. It is a story about a system with an enormous swing operating against a background that is quietly shifting underneath it. Which brings me to the last piece of this, and the one that made me want to make this video in the first place. Because the 30-degree anomaly of 2024 was not the largest departure Antarctica has produced. It is not even close. That record belongs to an event 4 years ago, and the number attached to it is the single most extreme temperature anomaly ever measured anywhere on the surface of this planet. Part 11. 40 degrees above normal. In March of 2022, surface temperatures in East Antarctica surged to as much as 40 degrees Celsius above the climatological norm. 40 degrees, that is 72 degrees Fahrenheit above where the temperature should have been. It stands as the largest temperature anomaly ever recorded in Antarctica, and by most reckonings the largest ever recorded anywhere on the surface of this planet. The attribution work on that event found that human warming amplified it by roughly 2 degrees Celsius, on top of whatever the circulation delivered. I bring it up now, at this point in the video rather than earlier, because it completes the range and because the comparison to Concordia is the thing I want you leaving with. Consider the two ends of what this continent has produced in the space of 4 years. At one end, minus 84.1 degrees Celsius, 5.1 degrees short of the lowest temperature ever recorded on Earth, achieved by sealing a high dry plateau under an intact lid and letting it radiate into the dark for months. At the other end, a departure of 40 degrees Celsius above normal, the largest anomaly ever measured on this planet's surface, achieved when that same lid failed and the atmosphere poured warmth into the space it had been guarding. Same continent, 4 years apart, one machine. There is no other place on Earth that does this. The tropics are stable, because the energy input barely varies. The mid-latitudes swing, but within bounds set by proximity to oceans and the reliable passage of weather systems. Antarctica is the only place where the presence or absence of a single circulation feature determines whether you are standing in the coldest environment on the planet or in an anomaly with no historical precedent. That is what I mean when I say that the variance is the story rather than the direction. If you took the average of Antarctica's last 4 years, you would learn very little. What you learn from the extremes is that the system has an enormous operating range, and that it is currently exercising all of it. The March 2022 event is worth a little more attention than a single number, because of when it happened and what it revealed about the season. March in Antarctica is the equivalent of September in the north. It is the transition out of summer, when the sun is dropping toward the horizon and the continent is beginning its descent into the cold season. It is not a time of year anyone would expect to see a record anomaly, and the fact that the largest departure ever measured on this planet occurred in that window rather than at the height of summer tells you something about how these events work. They are not about the sun, they are about transport. An anomaly of that size requires warm air to be physically carried from somewhere else and delivered onto a surface that had no way to warm itself. The energy did not arrive from above as sunlight. It arrived sideways, as moving air, through the same kind of atmospheric river structure that delivered moisture during the 2024 event. That is why these events can happen in the dark, and it is why the June melt on the peninsula this year happened without any solar contribution at all. It is also the reason the interior remains protected regardless. Air arriving from the middle latitudes cools as it travels and as it rises over the dome of the ice sheet, and by the time it reaches the plateau at 10,000 feet, whatever warmth it started with has been very substantially spent. There is one more detail from that year that I have not mentioned, and it belongs here because it connects the temperature story to the chemistry story. The 2024 season also featured a relatively weak Antarctic ozone hole, one that developed later than average and ranked among the smallest observed in recent decades. That is not a coincidence sitting next to the heat wave. It is the same thing seen from a different instrument. The chemistry that destroys ozone over Antarctica requires extremely cold conditions inside a well-isolated vortex, because it depends on clouds that only form in the stratosphere at temperatures below roughly minus 78 degrees Celsius. Break the vortex, warm the stratosphere, and you interrupt the conditions that the ozone destruction requires. So a disrupted vortex leaves a smaller ozone hole, and a smaller ozone hole means more ultraviolet absorbed in the stratosphere, which means a warmer stratosphere, which means a weaker vortex still. This is the same reinforcing loop I described earlier, running in the other direction. When the lid locks, cold begets ozone loss, begets more cold, begets a stronger lid. When the lid breaks, warmth begets ozone retention, begets more warmth, begets a weaker lid. The system has two stable modes, and it commits to whichever one it falls into. Now, I want to return to the sentence from the 2024 study that I flagged earlier, because it is the hinge of everything that follows. Although the event produced record-breaking temperature anomalies, most surface temperatures remained well below the melting point. That sentence is the reason the 2024 event was a scientific milestone rather than a global emergency. 30 degrees above normal in the interior of East Antarctica in August still leaves you at something like minus 30. It is a spectacular departure that changes nothing about the state of the ice, because the ice was never in any danger of melting at those temperatures. The interior has an enormous safety margin. The continent is so cold, so high, and so dry that even historic anomalies land nowhere near the threshold that matters. That margin is a property of the plateau. It is not a property of the continent. And this is where the two halves of this video finally meet. Concordia sits at 10,000 feet on 2 miles of ice, 700 miles from the sea, in 4 months of darkness. Its safety margin is measured in tens of degrees. You could hand that place the largest warm anomaly ever recorded, and it would still be frozen solid at the end of it. The Antarctic Peninsula is a different world, low elevation, surrounded by ocean on both sides, at the latitude where the Southern Ocean storm belt runs. Its margin is not measured in tens of degrees. In some seasons it is measured in single figures, and this June it was measured in nothing at all because for nearly 3 weeks the temperature sat above the melting point, and bare ground appeared at the base of the Collins Glacier. 2 Antarcticas. One where an anomaly is a number, and one where an anomaly is water. The whole question that this year raises, and the reason I wanted to build this video around a mechanism rather than around a headline, is what happens when the timing lines up wrong. We know the lid can fail because we watched it fail in 2024 in the most dramatic way the satellite record contains. We know that when it fails, warm, moist air is drawn poleward and cloud cover traps heat at the surface, and that the effect can be sustained for weeks rather than days. 17 consecutive days in that case. We know that the failures are not obviously becoming more frequent, because the study looked and did not find a trend in the circulation pattern's frequency, and we know that when they do occur, they now land against a background that has warmed enough to add roughly 0.7 degrees to the outcome, and to more than double the odds of crossing the extreme threshold, with projections running to as much as 26 times the natural likelihood by the end of the century under high emissions. Put those together, and the picture is not a continent slowly warming until the ice gives way. It is a continent that sits stable most of the time and occasionally gets hit by an event of enormous magnitude, where the magnitude of those events is creeping upward and the odds of the biggest ones are climbing. Now overlay that on the geography. The interior can absorb those events indefinitely. The margins cannot. So the thing to watch is not the average temperature of Antarctica, which moves slowly and tells you little. It is the coincidence of a major vortex breakdown with the part of the continent that has no thermal margin left, at the time of year when the sun is up. June's peninsular melt happened in the dark, 3 weeks above freezing without any solar input at all, driven entirely by the transport of warm ocean air. That is a preview written in the least favourable conditions for melting that exist. And there is one more question I have not been able to stop turning over since I started reading for this video, which is whether we would even recognise the first serious event when it happened. The 2024 heatwave was identified as record-breaking, studied, modelled and published, and the paper appeared in April of 2026, nearly 2 years after the event. That is not a criticism of the researchers, it is simply how careful attribution work operates. But it means that the way we find out whether a given Antarctic event was historically significant is by reading about it 18 months later. Concordia has one working weather station and a handful of people. The peninsula has a scattering of bases. The interior of East Antarctica, an area larger than the continental United States, is monitored by a small number of automatic instruments and by satellites measuring from orbit. We are watching the most thermally volatile place on this planet through a very small window. Part 12. The Wrong Moment. There is a lid over Antarctica made of wind, and everything in this video has been a description of what happens depending on whether it holds. This July it held. It held better than it has in over a decade, with the circulation index reaching plus 5.0 and most of a continent running more than 20 degrees below its own winter baseline, and at the sharpest point of that anomaly, a thermometer at 10,000 feet on the East Antarctic plateau read minus 84.1 degrees Celsius. The coldest air measured anywhere on this planet in 14 years, 5.1 degrees short of a record set 43 years ago. On that same day, on the outer flank of the wave pattern that same circulation was driving, a city in northwestern Argentina recorded the warmest night in 101 years of observation, 23.2 degrees above where it should have been in the coldest week of its year. 6 weeks earlier, on the finger of land reaching north from the same continent, 3 straight weeks above freezing in the middle of winter, left bare rock at the base of a glacier. 2 winters before that, the lid came apart under the earliest sudden stratospheric warming ever observed in that hemisphere, and a region of East Antarctica ran more than 9 degrees above normal for 17 consecutive days, peaking at 30.9 at a single station, in an event calculated to occur roughly once in 135 years and made more than twice as likely by us. And 4 years ago, the same continent produced a departure of 40 degrees above normal, which remains the largest temperature anomaly ever recorded on the surface of this world. Every one of those numbers came out of the same machine. That is the thing I most want to leave you with, because it reorganises how the rest of this decade's headlines are going to read. When you see a record cold reading from Antarctica and a record heat event somewhere else in the same week, you are not looking at a contradiction, and you are not looking at evidence that the people studying this do not understand it. You are looking at the 2 flanks of one wave, and the size of the gap between them is a measurement of how hard that wave is currently swinging. 136.8 degrees Celsius, this year, between the hottest and the coldest points on the planet. Wider than the entire span between ice and steam. We have spent most of the last 30 years arguing about the average. The average is real, and it is moving, and the ocean recording its hottest June ever measured at 20.98 degrees is the clearest statement of that we have. But the average is not what arrives at anybody's door. What arrives is the swing, landing on a background that has quietly shifted underneath it, so that the same old pattern doing the same old thing now reaches a little further past the edge of the record book every time it fires. The cold end of that swing has barely moved. A sealed plateau in the dark will radiate to the same floor it always did, no matter what we do to the atmosphere, and it will keep producing readings like this one for as long as the vortex exists. The warm end has moved a great deal. That asymmetry is the entire story, and it is why the coldest temperature in 14 years and the hottest June on record are not in tension. The floor is fixed, the ceiling is rising, and the distance between them is what we measured on the 18th of July. Before that, one number deserves restating, because it is the one that has done the most work in this video, and it is easy to lose among everything else. 0.7 degrees Celsius. That is the amount by which human warming intensified the 2024 event, according to the published attribution. It is a small number, and its smallness is the point. Nobody is claiming we built the vortex, broke it, or steered the air that poured through the gap. The dynamics were the atmosphere's own, and the study looked for a trend in how often that pattern occurs and found none. What we contributed was a slightly warmer starting point, and a slightly warmer starting point is enough to move an event from once in several centuries to once in one, and on the current high emissions trajectory towards something close to once a decade by the end of this century. So the question at the end of this is not which record matters more. It is a question about timing and about where. The interior of this continent can take everything the atmosphere has ever thrown at it and remain frozen. 30 degrees above normal at Dome Fuji still left the surface far below melting, and the authors of that study said so plainly rather than letting the number do work it had not earned. The margin on the plateau is enormous. The margin on the peninsula is gone. It ran out this June, in the dark, without any help from the sun at all. We know the lid fails. We know roughly how often, and we know that the frequency is not obviously climbing. What is climbing is what each failure delivers when it arrives, and the projections in the April paper run to as much as 26 times the natural likelihood of an extreme event by the end of this century. Which means the thing worth watching is not a trend line at all. It is a coincidence. A major vortex breakdown of the kind we have now seen twice, arriving over the wrong part of the continent, at the wrong point in the calendar, when the sun is up and the ice already has nothing left to give. That has not happened yet. Everything described in this video happened either over ice too cold to care, or over ice too small a piece to matter, or in the dark. There is one more thread I want to leave hanging, because it connects this story to the other great circulation question we have covered this year. At the end of June, we spent a video on the Atlantic overturning circulation, the system of currents that moves heat northward through the Atlantic and helps determine the climate of an entire hemisphere. That is an ocean system, operating on timescales of decades and centuries, and it is one of the two great heat distribution machines on this planet. The polar vortex is the other one, in the atmosphere, operating on timescales of days and weeks. They are not the same system, and I am not going to pretend they are directly coupled in some tidy way. But they are both examples of the same structural fact about this planet, which is that the distribution of heat matters at least as much as the total amount of it, and that distribution is handled by a small number of large circulations that can change state. The ocean one changes state slowly, and once changed would stay changed for a very long time. The atmospheric one changes state in a matter of days, several times a decade, and we have now watched it deliver both of the most extreme temperature outcomes this planet has on record. August and September are the months when the Southern Hemisphere stratosphere is most likely to warm suddenly and break the vortex before spring. The 2024 event came in early July and was the earliest ever seen. The climatologically favoured window is still ahead of us this year, so the plateau that recorded -84.13 days ago is sitting under a lid that has held all winter, in the part of the season when lids historically stop holding. If it breaks before spring, we will get to watch the same continent, in the same year, swing from the coldest reading on Earth in 14 years to whatever the other end of the range looks like now. The question is whether it holds.